Hello and welcome to Prototype and See, a brand new podcast for designers, engineers and innovators all about the product development journey. My name's James Murphy, co-founder of HLH, one of the world's leading manufacturers of prototypes and low-volume production parts. I've been in this industry for nearly 20 years, but I feel there's still a great deal about our customers that I don't yet understand. So, in Prototype and See, I'm going to be sitting down with some of the world's most innovative companies, talking to designers and engineers, all about the successes and failures, the ups and downs of bringing new products to market. Hi, hello, and welcome to the Prototype and See podcast. Today, we're very excited to have Jose Camero from Triditive, one of Spain's leading manufacturers of 3D printers. Hello, how are you?
Hello, James. Quite happy to having to this opportunity to be online with you in the podcast.
Okay, good. Yeah, very excited to talk to you too. Could you just tell us a little bit about Triditive and what you guys are up to?
Okay, Triditive. Yeah, I was, as you know, I was living in China for almost 5 years in Shenzhen, doing some product design mainly for OEMs and electronics and so on. Uh, that usually requires some electronic casing, some product design for at the end for prototyping. So you many projects get stopped in the phase that they will require the investment for the tooling for injection molding most.
Uh-huh.
So in one of my latest projects, I discovered 3D printing there. I'm talking about the year 2009 or something like that. So
So quite
yes,
a while ago then, yeah, very early.
I'm quite old, yeah. And
Aren't we
yeah,
all?
it was a Foxconn with it was a project with Foxconn and the Bank of China and Panasonic, and a very good project. And yeah, they took me to a factory. I don't remember the factory. And they have like a 3D printing service bureau internally.
Okay.
Plenty of SLA machines, SLS machines, and I was like, "Wow, what is this? What kind of magic is this technology?"
All right.
Uh, so I get amazed about that. Suddenly, I, I I fall in love with this technology. The real thing is something like passion or love.
Okay.
And that Christmas I came back to my country for Christmas, and I visit my school, my university, and go to visit some teachers and so on to check if we were doing something in additive manufacturing, and it was almost everything for to be done. So I had the opportunity to sell my company in Shenzhen to my partner, and I decided to start Triditive.
Okay.
That, that,
So
that,
so
that, that's the beginning. Yeah.
yeah, yeah. And I mean, what's the journey been like since then? Like how have things
Well,
developed?
the key point is that I decided to start up a company in Spain. That is quite
Oh,
difficult regarding legislation and all the regulations you have to do for a startup company. And
uh-huh.
also, we are talking about a hardware intensive startup. It's not.
Yeah.
I'm not telling that software startups are easier. Of course, everyone has its own um, milestones, right?
Yeah, but
But
hardware is notoriously difficult.
hardware is hard. I mean, the one who puts the name on that really knows what he was naming,
Yeah.
right? Hardware is
Uh-huh.
hard.
Yeah,
I have to raise capital for doing a factory, without
yeah,
any
yeah.
income and so yeah, yeah. So
Okay.
answering your question, the path was uh, hard. Also, I have
Okay.
yeah. But
Yeah,
now
yeah.
we are very happy with the results.
Yeah, but things are going okay. I believe you just got back from
Yep.
Formnext. Were
Yeah,
you?
yeah.
How did
We
that go?
went. Very, very well. Actually, we doubled the expectations we had from the previous year. Of course, we were introducing a new technology in there that always makes more people came into your booth and make questions and so on. The technology is not yet ready. Will be launched in Fornex next year, but there is a lot of hype in this technology in the market. So as we are doing this technology with Foxconn, we are very well now. Many people is waiting to see what we are doing, and we took one of the first prototype units to the fair, and we have massive quantities of people coming to the booth asking and trying to
Okay.
buy. It's awesome.
Good news. Good news. And then in terms of the technology, could you tell us a little bit more about that? Like, what makes your technology different from the competitors?
Yeah, at Triditive, as I worked before for Chinese factories, huge factories, I always understand or so manufacturing like a fully automated processes. I mean, if you want to scale up, you need something
Mm.
that can be scale up without
Mm-hmm.
scaling up the labor cost in the same proportion.
Mm-hmm.
So as you know, because HLH has a lot of power regarding AM also, uh, in the market, all the 3D printed machines we have, even the industrial ones, are not automated. I mean, you require for
Mm.
an operator to load
Yeah.
the resin or the raw material, check the print, load the print, remove the parts, clean the parts, and that requires a huge amount of labor. And
Yeah. Yeah. It's a
that
lot
is
more labor intensive
directly,
than people think, isn't it?
yeah, but a lot
Yeah.
more, yeah.
Yeah.
So I, when I started Triditive, I have manual desktop printers as many
Mm.
others, and I literally I get tired of waking up at 3 a.m. in the morning to go to the factory to replace some print jobs to
Uh,
be in the due date acknowledged with the customer. So uh,
yeah.
suddenly I realized like this should not be scale up because we will be a nightmare. So we started developing a fully automated industrial additive machine that can print in polymer, composites, and metals, and also a software that controls that factory, that AM factory, with orders, quotations, digital inventory, version control, user control, with a front end that the customers can connect and have their check the prints, how are their parts made, and many things. Yeah. So we started baby steps. Now we are more than 7 years in the market, and we have a very close and broad product to offer to.
Okay. So it's like a combination of hardware and software.
Absolutely,
Uh,
yeah.
Yeah.
Actually, we invested almost the same amount of money from our shareholders in, maybe it's not 50-50, 60-40 or something like that, but we invested a lot on the software also.
Uh-huh. Uh-huh. And which was harder? Was the hardware harder? Oh,
Uh, I think hardware is more visible. I mean, the money you invest in hardware is something that you see, so the shareholders is something easier to explain to them. And
yeah.
software, uh, to be honest, I will say is easy for me as a founder because I have uh, the most talented CTO that I ever found in my life. So I'm very
Okay.
very
You
glad
were
to
lucky then.
have him on
You were
board.
lucky then, yeah.
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 Yeah,
Yeah.
absolutely. Yeah, finding a good CTO that takes cares of everything and the decisions and programs almost everything is kind of how a software startup should be.
Yeah. And what about the development time? Like how long did it take from like the concept to having the actual physical printer prototype in front of you?
Yeah,
Like,
it's a very good question. I mean, we received the first investment in February 2018, and we introduced the first MVP from AMCell in Fornex in November in the same year. So
okay.
it took less than 1 year to
Yeah.
do everything from scratch.
Very fast, yeah, very fast. And what
Yeah,
what was the most
absolutely.
challenging aspect of that? What was the most difficult?
Yeah, well, we really need to start looking for providers. I mean, we
Mm,
are always mm, looking for reliable providers that can give us high quality parts, because at the end the parts that we get from the providers are those small bricks that builds our machines. And
mhm.
if the quality is not top quality, the prints that you will get in the end are not so good for our customers.
Okay, okay, yeah. And in terms of the technology again, is it's like FDM printing?
We have, yeah, we have two technologies. The
Mhm.
fully automated machine, the AIMCell 8300, is a FDM machine with
Okay,
the difference from the competitors that can print metal and polymers, even at the same time in different stations, parallelized. And
okay.
it's fully automated with a storage system and so on. And we have another technology that was the technology that we recently introduced in Fornex 2 weeks ago. That is a binder jetting, metal binder jetting technology.
Okay, okay, okay. And are there any plans to expand beyond that and look at other processes such as SLA or SLS, or are they less
Uh,
easy to
mm,
automate?
mm, mm, we started with FDM because it's the easiest way to, the easiest technology to automate, of course.
Yeah, yeah.
But now we have some projects ongoing for automate resin technology.
Okay, okay. That's a very different challenge, I think, isn't it?
Absolutely, but we can just use the at the end. Triditive is the core technology that we do is not FDM, it's not binder jetting, it's automation for AM,
It's the
both
automation.
hardware and
Uh-huh,
software.
uh-huh.
Uh, in the first machine, we developed the printer itself, plus the automation, plus the software. But in the
Yeah.
future, I'm seeing that probably we will not develop the machine itself, because there are plenty of machines in the market, very good ones with a lot of years of experience. We cannot do the best in every single step in the process, so we will partnership with them to automate their systems.
Okay, okay. And then in terms of like your ideal customers, like who do you see using your products, and what value will they get out of it?
Yeah, at the moment, as you know, additive manufacturing is a quite transversal technology. It can be used by many sectors. We are working a lot with the food industry to give them the technology to produce spare parts for the factories. That's
Okay.
a massive sector here in Spain and Europe. And
Mm,
we are also seeing that the big corporates like automotive, aerospace, but more humble manufacturing sectors are entering in AM. They already tested the parts, many of them also in FDM, because they
uh-huh.
are very at the end are very functional parts and last longer in time.
Mm-hmm.
Uh, but hey, they try the technology, they validate the parts, but if they want to scale up productivity, they don't find a machine to fit their requirement. That's where
Yeah,
AIMCell is targeting. That's the market we are
so
targeting. People who's
okay,
already using uh, AM and wants to scale up. Yeah.
okay. And it's mainly people who are using AM to manufacture many of the same part, or can it also be used to manufacture lots and lots of different parts?
Of course, as I like to say, AM is not like Harry Potter's magic one. Okay? It
Yeah,
requires design for AM, it requires validation and so on. So the
yeah.
perfect customer, if I have to choose, is the one that is already printing, I don't know, 100 different parts, but all the time the same. Okay?
All the
And they
time the
want
same,
to
yeah.
increase, yeah, yeah. But we
Mm,
have customers that are 3D printing service bureaus that they want just
mm.
to print different parts.
Yeah, and your technology can enable them to do that as well.
Yeah, of course. Yeah.
Yeah. Okay. And how do you think like 3D printing could help production companies become more sustainable? Is that something that's important to you guys?
I think sustainability should be something important for everyone that looks for the future. Right? Triditive is aiming the manufacturing of the future, so sustainability is key for us. Uh, we designed a machine that is very energy efficient,
Hmm.
very energy efficient. So it's more efficient than traditional manufacturing ways of doing parts. That's one point. And the other point is that we we don't use or we don't generate so much uh, waste material. I mean, we are not
Hmm.
subtracting from a bar of steel, for example. We are just adding the material in the right precision, right exact position the part is needed. So at the end, we can make lightweight parts that emits less CO2 if they are in a car or plane or anything that moves. Or and also regarding polymers, we are using biopolymers, a lot of them, especially for the food industry. That is one of our key sectors, and they are very concerned about sustainability.
Wow.
Uh, they ask for FDA, Food and Drugs approved materials, and with a very low CO2 emission rate, or some sort of green label on it, like biopolymer, biodegradable, and
Mm.
these kind of things. Yeah, we have many of them.
Okay. And do you think the fact that it's all automated will help with sustainability? Do you think it'll help reduce waste and issues like this? Or
I think that it will help sustainability in a little bit more complex way as automation will enable more factories to go into AM because
hmm.
they will be able to print more cost effective parts in a higher volume. They will integrate this technology in their factory plants so they will reduce their CO2 emissions and they bring uh, sustainability issues. Yeah.
Okay. Okay. But do you think 3D printing, because it's so fast and easy to use, do you think it encourages like a kind of waste culture where it's so easy to make something, you just make it and then throw it away,
Yeah.
whereas in the past it would have been much more difficult to do, and maybe you would have thought twice about it.
Yeah. So you will think twice before printing something, right? Yeah, because it was more expensive. And so.
Yeah, yeah.
It could be, but that probably is more regarded to hobbyists, probably do it yourself at home or these kind of things. But at the end, those guys usually employs biomaterials like PLA and these kind of things that
Mm,
are greater
mm.
than regular plastics. So I don't see that as a big issue for the technology.
Okay. And 3D printing's like it's currently maybe the fastest method of prototyping. Do you see anything coming in the future which could like challenge that? Say more
Another technology
prototyping.
that surpasses 3D printing or something like that. Yeah,
Yeah,
makes
yeah,
3D
more
printing
more
outdated.
exactly something maybe more prototyping in the digital world rather than in the physical. Uh,
Mm, as far as I understand the market and as far as I know the providers and so on, I don't have any idea of any other technology that is kind of preparing to be launched or something like that. I would say if those changes came into the market or someone launches this kind of technology, it will be some sort of 3D printing technology, in my opinion. Like
okay, okay.
CAD design to launch to the machine and start. manufacturing, some in some fashionable way or something like that. Yeah, but it should be some sort of 3D printing.
Right. And what are the like emerging kind of technologies or new trends within 3D printing have you seen that are interesting?
Uh, we recently got very hyped into this market with metal binder jetting, because
Right.
all the patents expired recently, and there are some big players entering in the metal binder jetting technology. So the price will drop, and at the end, binder jetting is a mass producing. It has the capability of mass producing parts very cost efficient
hmm hmm And in
in
terms
metal.
of like the you say you already have a binder jetting machine or you're working on a binder
Yes,
jetting machine?
yes, yes. Yeah,
You
we
have
were
one.
working with Foxconn the last
Right.
2 years to develop a machine, and the machine will be launched officially in Fornex next year, 2024.
Okay. Okay. And then in terms of like the actual machine itself, like how much were you able to reuse from your previous plastic polymer machine? Or did you have to start all over again?
It's a completely different technology. I mean, um, FDM is the filament fusing. It can fuse metal or polymer, and it draws the part in 3D.
Uh-huh.
Uh,
Uh-huh.
but binder jetting is a powder-based technology. So you lay down 50, 40 micron layer thickness of very fine metal powder, finer than metal laser sintering, actually. And then you have like inkjet print heads,
Mm-hmm.
very fast, like an inkjet printer. But instead of printing ink over a paper, you print binder, kind of glue, over the metal. So you
Mm-hmm.
get at the end you get very fast a green part that you have to put in a furnace and sinter, and you get the uh, final part. We are
Mm-hmm.
getting amazing results with the technology.
Okay. And does your machine automate the sintering of the green part as well, or is that
No. It's just we are working at the moment to launch the machine as a standalone unit, not automated, and all the post process is also manual at the moment. Of course,
okay?
we have in our tech roadmap, to automate binder editing, but it will take probably.
Okay. And what are the biggest use cases you see for this kind of technology then? Where do you see this being used in?
Uh, we are having some requests of meme producing metal injection molding companies. So they have some quotations for customers, but the customer did not or does not require a huge amount of parts. So injection molding, doing the tooling and so on is expensive, and they rather prefer to go into some AM technology if it's cheap enough. And by the
Yeah.
jetting, it is. And also we
Okay.
have, of course, we are working with Foscom, and they are wanting to print very small parts, very fine detail. At the end, you are printing like a inject, so you have like a photographic resolution on the metal. Awesome.
Okay.
Um,
Okay.
to print very small components for electronics, like hinges for laptops, antennas for cell phones, and these kind of things.
Okay. And then compared to other like metal additive technologies like laser sintering, for example, like where does it kind of stack up? Like what are the pluses and
Uh,
minuses?
m- uh, I would say that the major drawback that let's start for the worst part. The metal binder jetting requires post processing, a thermal post processing. Okay, uh, DMLS or metal laser sintering, you get the part. Of course, you have some sort of process to cut the part from the printing plate, and in case you have support material, you have to CNC the part to remove the the support structure that is fused with the part. And that's the main drawback. The advantage is the metal powder is kind of dirty cheap. We are talking about $25 per kilo. The particles are smaller, so the resolution that you can achieve at the end in the part is higher. Even the surface quality is much higher, and the process is much faster. I mean, you are not applying the energy to solder the particles with the laser, very fine laser. You are printing one layer in, I don't know, 3 seconds with a printing head, and you are not applying heat, so you can recoat another powder layer, print again, recoat, print again. It's crazy fast. I mean, laser sintering has its times. Yeah. At the end, the parts that you are working with metal powder that requires some kind of cautious measures, but you are not applying the energy to the powder, so you are just gluing it up with some binder.
Okay. All right. Okay. Thank you very much. What can we expect from you guys in the future? What's next?
Uh, the, 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 the next big thing we are going to launch to the market is the binder jetting machine. Probably we will communicate one of those partnerships we're collaborating now to still in an early stage, but doing some trials here in our factory in Asturias to automate another technology, 3D, 3D printing.
Okay. And if we want to find out a little bit more about you guys and what you're doing, where's the best place to do that?
Our website. If you drop an email to info@triditive.com, our team will receive and we will take care of proper answer as soon as possible. Yeah, to your requests.
Okay. All right. Thank you very much.
Thanks to you, James, and
Thank
good
you.
luck.
Okay.
Bye
Whether
bye.
you're working on your first product or your 10th, you've got the Prototype and See podcast to back you up through your product development journey. Follow, subscribe, and tune in for our next episode. We can't wait to see where your prototype takes you.